So in this exam style question, they'd like us to begin just by naming two baryons. And in this example, we should always just use the simplest baryons you can think of, which is a proton and a neutron. So now they'd like us to state the quark structure of the pion pi plus. And here we remember it's very simple. For the pi plus, that's positive. It must be made of an up quark, down quark, or an up. So it's either an up quark or an anti-down quark, or a down quark and an anti-up quark. For it to be positive, it must be the up quark and the anti-down quark, because up quark has a charge of plus through 2/3, and the down quark, anti-down quark, has a charge of plus 1/3. So that works. If we were unsure about this, remember we go back to our previous thing on the quark model, where remember we collected all of the different combinations of quarks that made up our pions, and remember for the pi plus it must be an up anti-down or an anti-down up, whichever way around you'd like to write it. And so that tells us that must be this. So after that, they're asking about the K plus kaon. So the K plus kaon is a strange particle. Give one characteristic of a strange particle that makes it different from a particle that is not strange. There's actually a few, so we're going to write all of them. That obviously you'd only pick one for the exam, but we should write down all of them so we know what we've got to choose from, because they might want to know a particular one later on, so it's good that whatever we could say, we know. So we could say it contains a strange quark. That's one answer. That is kind of the best definition of a strange particle, is that it contains a strange quark or an anti-strange quark. Or it takes longer to decay than would be expected, is another example. Or the final thing they would have accepted is that it decays via the weak interaction. Now that one is perhaps slightly ambiguous, because we remember the neutrons decay via the weak interaction and they aren't strange particles, but those are all particles that would have been accepted in the mark scheme, so I've written them all down here. But the best one to probably say, the easiest one, is to say a strange quark, because this one, it takes longer to decay than would be expected. That is very true about strange quark, a strange particle, and that's how they were originally noticed. It's just that, what does longer mean? Expected compared to what, that kind of thing. Whereas the most, clinical way of saying it is simply that it contains a strange quark. That's probably the simplest thing to do. Unless they've made it clear that answer isn't acceptable, in which case you would want to look at something like longer to decay would probably be the next best one. But if in doubt, saying it contains a strange quark is a perfectly acceptable definition of a strange particle. And the next question is on, these two reaction pathways we see for a strange particle to decay. So we have this K plus kaon decaying into things that aren't strange. They'd like us to state with a reason which of these decays is not possible.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.